So hello my colleagues, and I hope everyone is well. I want to pick up here on example 5.2. I think that's where we left off the last time. And here we are going to convert an annual percentage rate to a discount rate. Okay. So remember, this is APR, which stands for annual. The A is annual. That's important, right? Okay, so we're going to convert that to a discount rate. So let's read the problem together. Your firm is purchasing a new telephone system. Okay. So that's the first part, and it's going to last for this is going to last for 4 years. Okay. It's got a 4-year lifespan. Let's make sure we're clear. You can purchase the system outright, right up front. It's like buying a car for $150,000 with cash, right? Buying a car with cash. Or you can lease the system from the manufacturer. So here's your other option. Leasing it for $4,000 paid at the end of each month. Okay. So you can either part with $150,000 right up front or lease this at the end of each month. Your firm can borrow at an interest rate of 5%. Now this is an APR, and it's got semi-annual compounding, which means that whatever's left, they're going to compound it every 6 months. Okay. Should you purchase the system outright or pay $4,000 a month? Now let me just say this. I don't think this problem takes into account that if you do purchase it with $150,000 up front, they don't take into account in this example what you can do with that $150,000 as another investment tool if you decide to pay for it monthly. This would be like me. Here's what I do. This is like me buying a car and handing the guy $40,000 in cash for the car. He takes the cash at the dealer and invests it, right? And meanwhile, I got this car. I drive out of the dealer, and the car goes down in price by $5,000 because it's a used car now. I never ever buy a car for cash. I always try to get them for 0% financing, and I'll pay them every month. And I take the money that I have in my bank account and I invest it. Anyway, so be that as it may. So here's how it looks for the leasing the system for 4 years, right? It's a 4-year life at $4,000 a month. Here's the timeline. So let's look at that. So we look at the timeline, right? And that's pretty obvious, right? We can compute now. Again, we haven't gone over present value, but you can see that in chapter 4, I believe. We can compute the present value of the lease cash flows using the annuity formula. But first we have to get the discount rate that corresponds to a period of 1 month. Okay? It has to correspond to a period of 1 month. So we do this by we convert the 5% APR with semi-annual compounding to a monthly discount rate. Okay? So if we look at equation 5.2, again, we're not doing effective rate here. We got an APR, and it basically that's a 6-month rate of 2.5%. We divide it by 2. Okay, that's a 6-month rate because it's semi-annual compounding on the loan. Okay, that's why we're doing a 6-month. Okay, that's what they said. So to convert a 6-month discount rate into a 1-month discount rate, we compound the 6-month rate by 1/6 using equation 5.1. So now what we've got here is use equation 5.1, and what we've got to do is get an effective rate every month. This is an effective rate every month with compoundings with the 6-month compounding, whereby after 6 months it equals 5%. Okay, so you can see that right here, right? And here's the it equals 2.5%. So if you take this here and raise this to the 6th power, you'll get 2.5%. The other method we can use is we can go back to the equation 5.3, convert the APR, and I think a lot of people would rather do this. Convert the APR to an effective annual rate, right? So here's the effective annual rate. Then we can convert the effective annual rate to a monthly rate using equation 5.1 again. And it comes out the same way. And again, I think people would much rather do this. It's a lot more straightforward. All right. Convert the whole thing to an EAR. And then you can basically take that EAR, right, and subtract 1 and then get a monthly rate for that using equation 5.1. All right, so now we get the monthly discount rate because remember we're paying everything in a monthly, right? Remember everything apples and apples. So the present value now this is the present value of the monthly payments for 4 years. Okay. And how we would do that in Excel, it's so simple. 48 months. The only thing we have to know is we had to convert this rate right here. This is the rate, right? And here's the payment we made. And we're paying $173,867. So you could either use this equation or use Microsoft Excel. But the tricky thing is you got to get the monthly rate, okay? Because of the compounding problem. All right, so thus paying $4,000 per month for 48 months is equivalent to paying a present value of what we've calculated right here or right here. So now this is higher than the $150,000 that we would pay up front, right? So here's what they say, which I kind of don't agree with. It's better to pay $150,000 for the system rather than lease it. Now, here's where here's where my point is. My point is your original rate, your APR was 5%. And my feeling is if I took this $150,000, I could basically do a lot better than 5% if I invested it, okay? So I don't agree with what they're saying. So they say we can interpret this result as meaning that at a 5% APR with semi-annual compounding, right here, whoops, hold on. Let me highlight that. Very good. By promising to repay $4,000 per month, your firm can borrow $173,867 today. With this loan, it could purchase the phone system and have an additional $23,000 to use for other purposes. And I kind of don't agree with that. All right. So let me play this little video here, okay?
Converting the APR into a discount rate. Okay, you need a new phone system. You can either lease it for $4,000 a month or pay upfront $150,000 for the phone system. At the end of the lease, the phone system will be useless because it only lasts 4 years. To make this decision, what you need to do is compare the present value of paying $4,000 a month to an upfront payment of $150,000. Let's put the lease payments on a timeline. Okay, to determine the present value of these payments, we need to discount them, and for that, we need a rate. Now recall what an APR quote is. It is not the actual interest rate you earn, but simply a way of quoting interest rates. So if the interest rate, as it is in this problem, is quoted at 5% APR with semi-annual compounding, you are actually paying, in this case, because it's the loan rate, half of 5% every 6 months. So you're actually paying 2.5% every 6 months. Now, if you're paying 2.5% every 6 months, how does that now convert into a monthly discount rate? Because as we can see from the timeline, the cash flows are monthly. To answer this question, consider two loans. One loan, you have to make semi-annual payments of 2.5%. And the other loan, you have to make monthly payments. What monthly rate would make you indifferent between these two loans? You are indifferent between paying 0.4124% per month and 2.5% every 6 months. Now that we have the discount rate, we just use the annuity formula to calculate the present value of the payments. The payments are worth about $174,000. So you're better off paying cash today than leasing your telephone equipment.